Okay, so next we're going to talk about some of these complex derivatives. Now, most of these are on your formula sheet, or rather, all of these are on your formula sheet, but you only have to know a few of them. So the ones that I have highlighted here are the only ones that you have to have, that you have to understand. I went ahead and left the rest of them on here because I don't think it's a problem for you to know them. But these are the only ones that you're going to be tested over, and hopefully the only ones that you'll have homework over. I tried to sort out the rest of them, but just in case you get a different one, it's the same concept, just different equations. But these are the ones that you have to know for SL Math. So I went ahead and highlighted them, but we're going to go ahead and talk about where they come from. The first thing to remember is that derivatives, the first derivative is talking about the slope, right? So we're going to look at the function sine of u, and I want you to think about what the slope is at these different values. Here, remember at a maximum or a minimum, the tangent line is flat, meaning that the slope is 0. And if the slope is 0, then that means that the derivative's value here would be 0. So I'm going to find all of the maxes and mins and make their values 0. Okay? So from there, I can now look at the slopes at different points. So let's look at the slope here. Here at this value of 0, at x equals 0, the slope should be 1. So when I look at that slope, it looks to be a positive 1. So I'm going to place my value at 1. And then here at this point, it looks to be negative 1. So I'm going to put my point negative 1 there. Okay. Next, let's look at this one. Here's another negative 1. So I'll put my point at negative 1. And here, it looks like my point is positive 1. So I'll put a dot at positive 1. Oops, positive 1. So now I get to play a fun game of connect the dots. And when I play connect the dots with these values, what ends up happening is I have created a cosine function. So that's why the derivative of sine up here is cosine. So that's where that idea comes from. Now here at the end, there's this little du. This is called chain rule, and we will talk about that more next unit, but you do need to understand it for this unit. It's super easy, super straightforward. What it means is you're going to take the derivative, the du refers to the derivative of u. So for example, the reason why the derivative of sine of x is just cosine x. So I would take cosine of the value of x times the derivative of x. And the derivative of x is just 1. So we have du. So that would just be cosine x. But what if this equation instead were sine of x squared? If we had sine of x squared, then I would leave the inside the same. I would have cosine of x squared. But at the end, I would have to multiply it times the derivative of this x squared part, which is just 2x. So the derivative would be 2x cosine of x squared. It's pretty straightforward and pretty easy. but I can go ahead and talk through the rest of them. So we would have cosine of u gives you negative sine of u times the derivative of whatever is in the parentheses. Tangent becomes secant squared, and you leave the inside the same, but then you multiply it times the derivative of what's inside the parentheses. For natural log of u, it becomes 1 over u. So 1 over whatever is in the parentheses times the derivative of whatever is in the parentheses. And then the last one, e to the u, it stays the same, e to the u, but you multiply it times the derivative of whatever that exponent u is. So hopefully that's pretty straightforward. I think once you do the delta math, it'll make even more sense. All of those formulas are on your formula sheet, but the more things you can memorize, usually the faster test taker you become. So I encourage you to become familiar with these, but it's not a requirement for you to memorize them. All right, so go ahead and work on this delta math over the weekend, and we will do your review on Monday.